A bag of potting soil costs $12. It lasts one season. A bucket of weed tea costs nothing. It feeds your soil biology in a way no bag of potting mix ever can. The weeds you pull from your hardest ground, dandelions, nettles, comfrey, have roots that went down 18 inches into clay and pulled up calcium, potassium, and phosphorus that your vegetables could never reach. Steep those roots in water. Pour what comes out on your garden. The soil starts changing within one season. Two things explain why almost nobody in the modern gardening world does this. One involves what is actually inside a dandelion root. The other involves who profits when you keep buying bags every spring. By the end of this video, I will show you exactly which weeds to pull, exactly how to steep them, and exactly what comes out that your vegetables have been missing. But first, you need to understand why the weeds growing in your hardest, most compacted ground are not your enemy. They are a signal, and once you learn to read them, you will never look at a dandelion the same way again. Pull a dandelion from compacted clay soil, look at the root. It is not the short, fragile thing you find in loose garden beds. In hard ground, a dandelion taproot goes straight down 15 to 18 inches, sometimes further, through layers of compacted soil that your garden fork cannot penetrate, through clay that your spade bounces off, straight into the mineral-rich subsoil that has been untouched by anything you have ever planted in your garden, beds above it. That root did not grow there by accident. Dandelions are what soil scientists call indicator plants. They appear in compacted, calcium-deficient soil specifically because they are equipped to survive there and to begin the slow process of fixing what went wrong. The taproot physically breaks up the hardpan as it grows, creating channels for air and water to penetrate. As it grows and eventually dies back, it leaves behind organic matter and a network of tiny channels that earthworms and soil organisms move through. The dandelion is not growing in your hard ground despite the problem. It is growing there because of the problem, sent by the soil itself to begin correcting it. The Old Farmer's Almanac states it directly. Dandelions and burdock are common signs of compacted soil. Their deep, strong roots are breaking up that soil. The weed you have been fighting is doing remediation work that you would otherwise need an aerator and a bag of amendments to even begin. Now here's what that root has been pulling up while it was down there. The minerals that make fruit set, that make roots develop, that make leafy growth dark and dense, do not sit in the top 6 inches of soil where you pour your bagged amendments. They accumulate at depth, washing down through the soil profile over years until they reach layers that most garden roots simply cannot. Access calcium, potassium, phosphorus, iron, magnesium. A dandelion root going down 18 inches finds all of them and pulls them up into its leaves and stems and stores them there, concentrated, waiting. There is a practical way to see this working. Pull a dandelion from hard calcium-deficient clay soil and pull another dandelion of the same size from a loose, rich garden bed. The root from the clay will be longer, darker, and thicker than the root from the garden bed. The clay dandelion worked harder to reach minerals. Its root holds more of what it found because it had to go deeper to find it. The same mineral density that made it a successful survivor in poor soil is what makes its root valuable in a bucket of water. When you pull that dandelion and throw it in the trash, you have just removed 18 inches worth of mineral mining from your garden and sent it to a landfill. When you pull it and steep it in water, something different happens. Two things explain why weed tea works at a level that bagged amendments struggle to match. One involves the microbial life in your soil. The other involves the form that nutrients need to be in before plant roots can actually absorb them. A bag of granular fertilizer delivers nutrients in their raw mineral form. For a plant root to absorb them, those minerals first have to be processed by the microbial life in the surrounding soil. Broken down into forms that dissolve in soil water, made bioavailable by bacteria and fungi doing their work in the rhizosphere around each root tip. If your soil biology is depleted, which it almost certainly is if you have been using synthetic amendments for more than a couple of seasons, the granular fertilizer sits largely unused because there is not enough microbial activity to convert it into anything the roots can take up. Weed tea is different in a specific and important way. The fermentation process that happens when plant material steeps in water begins breaking down the plant compounds immediately, releasing nutrients into the liquid in forms that are already partially bioavailable. More importantly, The fermenting tea becomes colonized by beneficial bacteria and fungi that, when poured onto garden soil, inoculate the soil biology directly. You are not just adding nutrients, you are adding the living organisms that make nutrients available. The only published study I found that actually measured the NPK of fermented weed tea tested 3 species: water, hyacinth, Russian comfrey, and pigweed, and found an average NPK of roughly 3% nitrogen, 7% phosphorus, 4% potassium after 30 days of fermentation. That study ran for 30 days at full concentration before testing. 2-week tea, which is what most home gardeners make, will have lower values. But diluted 10-to-1 before application, the 2-week batch still produces a liquid fertilizer at around 0.3% nitrogen, which sits in the range of commercially available liquid feeds sold at garden centers for several dollars a bottle per application. The difference is that what comes out of a bucket of steeped weeds also carries the microbial life that no commercial product in a sealed plastic bottle can provide. Bottled liquid fertilizers are sterile by design. They cannot contain living organisms because living organisms would continue consuming the nutrients during storage, degrading the product before it ever reaches your garden. The trade-off between shelf life and biological content is built into every commercial liquid fertilizer on the market. Weed tea makes the opposite trade-off. It is fresh, biologically active, and slightly different every batch depending on which weeds you used and how long it's steeped. That variability is a feature, not a flaw. It mirrors the biological variability of healthy soil itself. Here is where conventional soil amendment falls apart completely. The gardening industry sells you the idea that soil health comes in a bag of potting mix, a bag of compost, a bottle of liquid fertilizer, a packet of granular slow-release amendment. Each product addresses one specific deficit, delivered in isolation from the living system that actually determines whether a plant can use what you are giving it. You pour nutrients onto soil that is biologically depleted, and a fraction of what you poured ends up available to your plants. The rest washes through or locks up in mineral complexes the roots cannot access. Consider what happens when a bag of potting mix is opened and spread across a garden bed. It delivers a standardized mixture of peat, perlite, and mineral amendments that was formulated in a factory with no knowledge of what your specific soil was missing, what your specific plants were being asked to produce, or what the microbial community in your garden actually needed to function. It is a generic product designed to be acceptable for every situation, which means it is optimal for none of them. It performs well enough in a container where there is no existing soil biology to consider. In a garden bed with an existing soil ecosystem, it can actually disrupt the biological balance you have been building by introducing a sterile, high-mineral medium that temporarily flood fertilizes while contributing nothing to the microbial life that does the long-term work. Weed tea feeds the system, not just the plant. The bacteria and fungi that colonize fermented plant material are the same organisms that form symbiotic relationships with root tips, that mineralize organic matter into plant-available nutrients, that protect roots from pathogens, that regulate soil pH at the micro level. A garden with active, diverse soil biology needs fewer amendments of every kind because the biology is doing the conversion. Work that bagged products try to skip. The dandelions, nettles, and comfrey that grow in your hardest soil are already doing this work underground. The tea you make from them carries that process into your garden beds. Now, let me show you which weeds to use and why each one matters. Dandelion is the most important and the most available. Its taproot accumulates calcium and potassium from deep subsoil in concentrations that most garden soil lacks at the surface. The leaves carry the same minerals in high density. Use the whole plant, root and all. Dandelions growing in compacted clay soil have been mining that clay for calcium for however long they have been there. Everything they pulled up is in the plant tissue. When it steeps, it goes into your liquid. Stinging nettle is what you add when your plants are hungry for nitrogen. Nettle is a nitrogen accumulator, which is why it grows in rich biologically active soil, and why its presence is often an indicator of high soil fertility nearby. The leaves and stems carry nitrogen, phosphorus, potassium, calcium, iron, boron, zinc, and magnesium. Wear gloves when harvesting, long sleeves too. The sting comes from tiny hollow hairs on the leaf surface that inject a mixture of histamine, serotonin, and formic acid into anything that brushes against them. The sting disappears entirely once the plant has been steeped for a few days, the compounds breaking down in water. Harvest before it flowers if you can, when the nitrogen content is highest. Comfrey, you already know if you have watched this channel. Its taproot goes down past 6 feet, past the compaction layers, past the hardpan, into subsoil that nothing else in the garden can reach. The potassium content of comfrey leaf at flowering is approximately 5% dry weight, higher than farmyard manure by most measures, and more than twice the potassium content of most bagged amendments. Comfrey tea, made by the same bucket method, is the specific liquid feed that shifts a plant's energy from leaf growth into flower and fruit production. Tomatoes poured with diluted comfrey tea at flowering time consistently outperform the same variety poured with commercial tomato. Fertilizer containing equivalent potassium, because the microbial fraction in the comfrey tea delivers the potassium in a form the plant can use immediately. If you have comfrey growing anywhere on your property, it belongs in every bucket of weed tea you make. Thistle grows in compacted, heavy acidic soil and sends roots deep to bring up iron and moisture from subsoil. Plantain, the flat rosette weed that appears wherever the ground has been walked on and compressed, accumulates calcium, magnesium, silicon, sulfur, manganese, and iron. Horsetail, the ancient jointed weed that grows in moist or poorly drained ground, pulls silica, potassium, and iron from deep mineral deposits. Yarrow, which appears in potassium-deficient, sandy dry soil, brings phosphorus, copper, and potassium up from depth. Every hard-ground weed you have ever pulled and thrown away was doing a version of the same thing. The soil sent it there to mine minerals and break up compaction. The tea you make from it carries the product of that mining straight back into your garden. Here is exactly how to make it, and it requires nothing you do not already own. Take a 5-gallon bucket with a lid. Fill it 2/3 full with whatever weeds are available to you right now, chopped coarsely. Roots, leaves, stems, all of it. The softer the plant tissue, the faster it breaks down, and the faster the nutrients enter the water. A dandelion leaf breaks down faster than a dandelion root. Both belong in the bucket. Pack the weeds down into the bucket as tightly as you can. The more plant material per volume of water, the more concentrated your final tea, and the more you can dilute before applying. Cover the weeds completely with water, either rainwater or tap water that has been left out overnight to allow the chlorine to off-class. Chlorine in tap water kills the microbial life you are trying to cultivate. This matters more than almost any other detail in the process. Fish tank water, if you have it, is ideal. It already contains nitrogen from fish waste and an established microbial community that will accelerate the fermentation. Rainwater collected from a roof is second best. Tap water left overnight is adequate. Fresh tap water straight from the tap will work, but slowly. Put the lid on loosely, not sealed. The fermentation process produces gas, and you do not want the bucket to build pressure. Stir the bucket once a day if you can. The stirring adds oxygen to the mix and accelerates microbial activity, particularly in the first week. If you forget, stir it when you remember. 1 stir a day is ideal. 3 stirs a week is fine. 0 stirs produces a slower, more anaerobic fermentation that still works but takes longer. Place the bucket somewhere out of direct sun so the water does not overheat and kill the microbial activity you are building. Temperature between 60 and 80 degrees is ideal. A shaded corner of the yard, a garage with a window. Anywhere the water stays cool and the process can run at its own pace. One honest warning, this mixture is going to smell. Not unpleasant in the way of rotting food. Closer to pond water, green and biological. The smell is the fermentation working. Keep the bucket where the smell is not a problem, away from sitting areas and downwind of the house if you can manage it. The smell tells you it is working. A bucket that does not smell is usually a bucket with no microbial activity. After 2 weeks, the plant material will have broken down significantly. The water will be dark, green, or brown depending on which weeds you used. Strain out the solid plant material, which goes straight into your compost pile or directly onto a garden bed as a surface mulch. It is still biologically active, and the worm activity it attracts is worth having in any bed that needs biological activation. Dilute the liquid 10 parts water to 1 part tea. You are aiming for a color like weak tea. Too concentrated and it can burn plant roots, especially on young seedlings. At the 10-to-1 ratio, it feeds without any risk of burning. Pour it around the base of plants, not on the leaves. Apply every 2 weeks through the growing season or whenever you have a fresh batch ready. Replace the solid material with fresh weeds and top up the water to keep the cycle going all season. One bucket, running continuously from spring through fall, can supply enough liquid feed for a substantial vegetable garden without purchasing a single bag or bottle of anything. The potting soil industry sells you the same product every spring, the same mineral-depleted growing medium, the same slow-release granules that need a functional soil biology to do anything. The same cycle of purchase and depletion that begins again the moment the bag is empty. It requires you to keep buying because the product does not build the system that would eventually make itself unnecessary. A bag of potting mix does not leave your soil better than it found it. It leaves it dependent on the next bag. There is a reason no gardening brand advertises that their product will make itself irrelevant over time. There is a reason extension programs publish guides on fertilizer schedules and application rates, but rarely publish anything on building the soil biology that would reduce the need for fertilizer in the first place. The market for soil amendments depends on soil that remains amendable indefinitely. A garden with genuinely healthy, biologically active soil, the kind that forms when you stop stripping the biology out and start feeding it, uses dramatically less of every product the industry sells. That outcome is good for the garden and neutral to bad for the companies selling bags every spring. The weeds growing in your hardest ground are building that system right now, 18 inches down, where the minerals are, where the clay is breaking up, where the channels for air and water are forming through root growth and decay. They are doing for free, underground, what the gardening industry charges you for season after season in bags that last one spring. Pull them, steep them, pour what comes out on the ground they came from. The soil will start to change. The biology will activate. The plants will begin to look different, darker, more vigorous, more rooted. Not because you bought something new, because you stopped throwing away what was already working. If you found this useful, watch the next video and do not forget to subscribe. See you in the next one.